Blockchain and cybersecurity, strengthening digital protection. Blockchain technology is often associated with cryptocurrency transactions because it is a more secure method of sending protected, secure transactions. However, what many don't know is that blockchain can also be used for business purposes to send protected, more secure communications that are safer than traditional networks. So how does cybersecurity play a role in current blockchain technology? Cybercriminals are increasing the frequency and sophistication of cyber attacks by pooling their knowledge and leveraging new technologies. Their use of artificial intelligence, AI, machine learning, and botnets help them perpetrate cybercrime more efficiently, causing more profound and widespread damage. Traditional solutions alone are often insufficient to meet modern cybersecurity challenges. So we must explore other approaches for improving information security, including blockchain technology. In addition, businesses have faced new challenges, such as mitigating vulnerabilities when more staff work remotely. Using personal devices and new collaborative software to connect and transmit data to business networks. This post helps organizations manage the 3 steps required to drive successful, secure blockchain implementation. Understanding the cybersecurity risks of using blockchain. Enforcing blockchain's unique security controls and making the most of their advantages. Implementing traditional cybersecurity best practices. What is blockchain? The blockchain, according to IBM, is a shared, immutable ledger that facilitates the process of recording transactions and tracking assets in a business network. It is a system for tracking anything with value securely, transparently, and cost-efficiently. The name blockchain comes from the fact that each transaction is recorded as a block of data. A block might record one or more data types, such as quantity, price, or location. These blocks become a chain as the asset moves from owner to owner. The chain contains the details of each transaction, including their times and sequence. A blockchain has no single point of failure. Every chain is immutable, so no participant can break a link to insert a block. It's almost impossible to tamper with one of these cryptographic chains because an agreed consensus mechanism validates the accuracy of every transaction in the chain. The owners of assets on blockchains can be practically untraceable, making the technology useful to cybercriminals receiving ransomware payments in cryptocurrency, such as bitcoins. However, businesses and cybersecurity professionals can also use blockchain technology. How cybersecurity impacts blockchain technology. Cybersecurity is built into blockchain technology because of its inherent nature of being a decentralized system built on principles of security, privacy, and trust. In addition to transparency, cost efficiency, and enhanced security, it is fast. Data on a blockchain network is delivered in real time, making it useful to anyone who wants to track assets and see transactions end-to-end, such as payments, orders, and accounts. It's important to note that viewing transactions or transmissions may be instant, but due to encryption and serialization processes, each record can be slow to upload compared to typical data networks. Furthermore, the U.S.'s Defense Advanced Research Projects Agency, DARPA, has been working with blockchain technology to create a system that deters and prevents hackers by not only immediately flagging attempts to compromise data but also providing real-time intelligence on the bad actor. Blockchain's inherent cybersecurity benefits include the following. Decentralization. A blockchain uses a decentralized distributed ledger system rather than relying on a single trusted central authority. With distributed ledger technology, DLT, transactions are recorded across every network node, so cybercriminals face challenges viewing, stealing, or modifying data. It is designed to create trust amongst participants in areas where trust is hard to come by. Collaborative consensus. Blockchain's collaborative consensus algorithm means that it can monitor the ledger for unusual or malicious activity. Strong encryption practices. Blockchain networks use encryption and digital signatures effectively, using public key infrastructure for validating configuration modifications, authenticating devices, securing communication. An infrastructure of asymmetric cryptographic keys and digital signatures is often core to blockchain technology, providing verification of data ownership and data integrity. In some cases, these elements eliminate the need for passwords, an attack vector through which cybercriminals frequently gain unauthorized access to accounts and networks. Immutable records. Nobody can modify a recording on a blockchain ledger. If a record contains an error, it can only be rectified by making another transaction, in which case both transactions will be legible. IoT protection. With increasing applications in various industries, Internet of Things, IoT, devices are often targeted by cybercriminals due to their inherent vulnerabilities. Blockchain provides additional protection for those using IoT devices. Preventing DDoS attacks. A distributed denial of service, DNS, attack aims to overload a server with requests. It requires a focal point to target, typically an IP address or a small group of IP addresses. However, a blockchain-based domain name system, DNS, can remove that single focal point, neutralizing this cyber threat. Data privacy. While its transparency is a prime benefit of using blockchain, with everyone able to see immutable transactions, a permissioned blockchain network will allow only trusted networks to view or participate in transactions. This can be achieved with minimal governance. Furthermore, blockchain lacks the traditional targets sought by cybercriminals, making it more challenging for them to achieve unauthorized access by targeting privacy rules. Smart contract security. Smart contracts are sets of rules stored on the blockchain that trigger transactions when the conditions are met. This automation makes payments more convenient. Blockchain remains secure because its components are tested for authentication, data security, access control, and business logic validation. Traditional cybersecurity best practices and blockchain. When implementing an enterprise-level blockchain network, whether to track currency, orders, accounts, or other digital assets, traditional cybersecurity best practices will enhance blockchain's inherent security advantages. Risk management. Just as with the implementation of any business system, a thorough risk assessment and subsequent management process are required to ensure data protection and the safety of business systems. Regulatory focus. Heavily regulated industries aim to protect the public and critical infrastructure with clear guidelines regarding information security. Any blockchain implementation should be carried out with a close eye on regulatory requirements. Disaster recovery plan. An organization's disaster recovery plan must be updated to incorporate its blockchain technology. It must contain the names and contact details of the participants. Minimum security requirements for blockchain participants. An organization implementing a blockchain solution requires detailed policies on identity verification and access management. This is a critical area for blockchain applications since it's a potential source of strength and contributes to a firm's vulnerability. Security infrastructure. Since blockchains can be compromised by the theft of keys and unauthorized access to staff devices, the blockchain must be implemented in an environment with an effective cybersecurity structure. Blockchain security considerations. Despite the inherent privacy and authentication advantages of using blockchains, it's important to note they are not invulnerable to cyber attacks. Organizations implementing blockchain solutions must use the best cybersecurity practices company-wide and examine blockchain-specific risks and cyber solutions to ensure information security. If you find this video useful, don't forget to like and subscribe to our channel.